Okay. So let's do a quick summary for those people who um, are watching this video. Okay, so we're doing translation problems. With translation problems, there's two issues. One is that normally when you have something that says 5 less than 2, 5 less 2, 5 subtract 2, you keep the numbers in the same order in which they're written. 5 minus 2, 6 divided by 2, 6 divide 2. Okay. Now, there are two words that'll make you flip the order of the numbers. Those words are than and from. So if you have 5 less than 2, the 5 and the 2 switch sides, right? Reverse the order of the numbers. Same thing as if you get the have something like 6 divided from 2, you reverse the order. Okay. Now, the other issue, let me take a picture of this. Okay. The other issue is that when you're given a problem like this, so let's read this like this. Okay. 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 There is an arbitrariness to how you solve this. It depends on where you put your pause. 5 less 2 times a number, or 5 less 2 times the number. Now, normally in English, what we do is we put commas and they denote what goes with what. So if I put my pause here, I go 5 less 2 times the number. We know that we get a parentheses here and here. So this problem would be 5 minus 2x is equal to 6 minus 2x is equal to 1, x is equal to negative 1/2. And then over here, because our comma is here, we have a parentheses here and a parentheses here. And we get 5 minus 2 parentheses times x is equal to 6. So now, so I get 3x is equal to 6, x is equal to 2. Okay. Now, when we look at this, there are no commas to tell us where the parentheses should go. Now, the way you find the parentheses is you first find the word that means equal. So in this problem, it is here. Okay. Now, we see that we have two operators, and we have to know, what do I do first? You always do the rightmost operator first. So this turns into 5 minus 2x equal to 6. So basically it turns into this situation right here. Okay. Now, let me give you a different problem to try. Okay. So let's erase. Let's just do a few of these. So that was our recapper. So with the translation problems, those are the two issues you have to worry about. Okay. So let me give you something on the level that you would see on the TEAS. So you would look at something like twice a number subtracted from 6 is the same as 3 less 4 we'll go, yeah. Let's go 8 divided by 2. All right, and then go ahead and find that number. Okay, so let's look at that. So let's find the word that means equal. So I have the word equal over here like that. So now I'm only looking at the left side and I'm ignoring the right side. And that's what finding the equal does, is that it removes a lot of the complexity. Okay, so let's go right to left, right? I have a multiply here and I have a minus, and I have the word from. So we're going to have to reverse the order. Okay, but first of all, I have a number subtracted from 6. Okay, so that's going to be, reverse the order, 6 minus x. And then you're going to go twice, and then you're going to have 2 times like that. Okay. And then we have our equal. And then let's go backwards here. Now, notice that this word is by. There's no word by over here. By does not reverse the order. So this over here, okay, when we go backwards, that'll just stay like it is. 8 divided by 2. And then 3 less is 3 minus. So ultimately what I get is 2, 6 minus x is equal to 3 minus 8 divided by 2, 12 minus 2x, and then 12 minus 2x. So minus 2x is equal to minus 13, and x is equal to like that.
I have a question, Professor.
How can I help you?
Twice a number subtract from 6. Twice a number subtract from 6. 看来到 6 minus 2 times x. 6 minus 2 times x.
No. Remember, these two go together. This, right? What's this? So what you're looking at only, you're ignoring this part now. A number subtracted from 6.
Mhm.
So what this right here, you're ignoring everything else,
Mhm.
is 6 minus x.
Yes.
After you finish that, then you go twice.
Okay, got it. Thank you so very much.
Is that better? Okay.
Yeah.
So even though this from, because I put the parentheses here, it lets me know that it's only within this parentheses that we're doing that. Okay. So if you think this is hard, you're correct. None of this is easy. Anyone else have questions?
Can we do one more example?
Oh, we'll do a bunch. We'll do a
Oh.
bunch. Okay. So none of this is easy. We're going to do a few of these. Okay. Okay. So let's try it again. Okay. So let's say the sum of a number times a number, let's say subtracted from 5 is equal to, let's say, let's see, 2 Okay, let's try that one. Oh, I forgot something. It's the sum of a number. Oh. Sorry. And 6 is equal to, okay, sorry about that.
Professor,
Mhm.
Professor,
Yes.
I got a parentheses 5 plus 6 parentheses minus number minus x equal to 3 times
Well,
x.
let me
minus
try it.
7.
Let's try it. Okay, so let's go. Here's my equal. Okay. Now the things that we're looking for are the operators, not the numbers. Right? What's confusing here is the 5 and 6. It would sure help if I had a comma to tell me like what's connected to what. But remember the key thing here. We're looking for operators, not the numbers. So the only two operators that are here is plus and minus. So what I want to do is the minus first. Okay. So a number subtracted from 5. That's why these are connected. Okay. So this has the word from. So we're going to reverse the order.
From 5 and 6. Professor, from 5 and 6.
Not 5 and 6.
Just
You
why
can't
just the 5?
do, huh? It's just the 5, yes. So you have 5 minus x. Right? Now you say the sum of this and 6. Okay. So what you're trying to do is find the innermost operator, right? A number subtracted from 5. I stop. I put parens around there, and I know ignore the rest of the world. And then I'm saying the sum of this and that. Okay, so not easy. Okay. Now let's do this one over here. Okay. So let's go backwards. What I have is a multiply and a subtract. What I'm going to do is go backward. We're going to do the multiply first. 3 times the same number. So we're going to go like this. Okay. And then subtracted from 2. So this has the word from. So we're going to reverse the order. So instead of 2 minus this, we're going to do this minus 2. So we end up with 5 minus x plus 6 is equal to 3x minus 2. Okay. And then we'll let you solve it. We ran out of board, so I just want to get you to do this translation part. Okay. Does anyone have questions on that? Because that was not easy. That's about as hard as it gets. Let's try some more. Six less than twice a number amounts to the difference of 5 plus the same number and 10. Okay, give this one a shot. All right. Now this is poor English because they didn't put commas in there to clarify it. But unfortunately, we're mathematicians and we have poor English. And then we say, understand us.
Professor, I couldn't solve this one. So is it
Oh,
possible?
you want me to do it? Yeah, I could do it. Okay. So is it okay if I erase this top part? I just ran out of room, that's why.
Yeah, sure.
Okay, so let's erase this. Okay. So I have 5 minus x plus 6 is equal to 3x minus 2. Okay. Now, in between the parentheses and the plus is a, in the parentheses and the 6 is a plus. So we really actually don't need the parentheses. We're not actually distributing. Okay. So now what we're going to do is we're going to combine like terms. We're going to combine the numbers on that side, the numbers and the x's on that side, the numbers and the x's on this side, and we don't cross over. So I'm going to add this 5 plus 6. So I get minus x plus 11 is equal to 3x minus 2. And now we'll bring x's to one side. And then we'll bring numbers to the other. And then we'll divide both sides by minus 4. I get x is equal to 13 over 4 like that. Is that better?
Yeah, thank you, Professor.
Okay, and is there any part of that that you didn't understand? You just let me know, and we'll go into more detail.
Yeah, no, because of the parentheses, I got confused. Sorry.
Yeah, this will throw people off because they'll think they have to distribute. But I get you.
Professor,
Mhm.
use use this the same number. I don't understand the same number. Same number is that mean is x.
Yes, yes.
Is a
So
same number
this
that mean
is
is.
This is x and that's x.
Oh, okay, got it, thank you.
So if I didn't put same, it could be some other number, although it's probably the same number.
Okay.
So the same number means this one and this one are the same variable.
Okay, thank you.
Now, here's my equal. And when we go twice the number, we're doing this right here. Right? Oh, I'm sorry. Let me slow it down. Let's look at our operators. We have a multiply here, and we have a minus there, and we have the word than that we have to be careful. So we want to say, what does this multiply apply to? It applies to this, twice a number. So that's what we're going to do. Okay. So 6 less than this. So this tells me the reverse order. So I'm going to go 2x minus 6 is equal. Okay. Now, when we do this one, let's go backwards and find our operators. This is a plus and this is a minus. Okay. So the difference, 5 plus the same number. So that is what I'm doing with my 5. Right? And there's nothing in there that tells me the reverse the order. 5 plus x. And then we do the difference. Keep the same order. There's no than, there's no from on this second half, this right half, right? So same order. This whole thing with the parentheses minus 10. So at the end of the day, we get 2x minus 6 is equal to 5 plus x minus 10. And then this turns into 2x minus 6, 5 plus x minus 10. And then let's combine like terms.
X equal to -4.
So I get 2x minus 6 is equal to x minus 5. Then I subtract x, add 6, add 6. X is equal to 1.
Professor, I got X equal to -4.
-4? Okay.
Yeah.
Did you get this line?
That means 2 times minus X equal to 5. 2 times minus X equal to 2 times plus 6. Oh, yeah. 2
Yeah,
times
got it.
plus 6.
Okay. So some people were taught to do this, right? Some people were taught, and this is totally fine. If you're Armenian, Russian, if you're from the Philippines, I don't know what they do in China. But
Professor,
some people were taught to,
X equal to 4. 实际上是 X equal to 4.
let's see. Did I mess it up? I could have. So some people were taught to do this. 2x minus x is equal to -5 plus 6. So then you get x is equal to 1.
I'm wrong, Professor.
Yeah, this is
Huh?
simple.
Say that again.
I have never seen that.
I have seen this. My dad taught me this, and I think it's simpler to understand. I think.
Yeah, which country did you which country did your dad do his education in?
Uzbekistan, part of Russia, used to be Russia.
Okay, yeah. So the thing is that the first thing you do when you take over a country is you take over the education system. So you can see in Ukraine, in the occupied territories, the first thing they did when they took over the areas in Luhansk and Donbass, they sent a whole bunch of teachers. So the teachers go in there and they go, hey, you're part of Russia. You shouldn't speak Ukrainian. Ukraine's bad. There's a lot of Nazis there. And the other thing too is that you're going to learn our educational system. So they go there to indoctrinate people of, I know we've taken over your country, but it's for your good. And in the process, they teach you their version of math. It's not that this math is different. They've organized it different. So anyone that has, any country that has any relationship to a communist imperialism, right? So that's why like Venezuela, El Salvador, but only half of El Salvador, the half that is controlled by the Contras, they'll do it this way. The United States will do it this way.
They usually try to manipulate their way,
Yeah, but this is a math class, not a politics class. So for those of you who go like, how'd you know my dad was from Russia or a Russian controlled state? And like,
it's in history. Russia they used to control Uzbekistan too. We don't like Russia too.
yeah. So I hear you. So I had a student who was from El Salvador and he had immigrated to the United States, and I like, oh, you're from the Contra side of El Salvador. He's like, how could you possibly know that? Like, oh, I graded your test. The American side, they did it like this. So I know where you grew up. Okay. Let's work on, do you guys want one more, or are you ready to go on the next thing? Okay.
I wouldn't mind one more.
Let's do one more. Okay. So let's try twice a number less than 8 is equal to the quotient of 4 times 2 and 8. Oh, you know what? Let's go. I'm sorry. Let's do this. 10 plus 6. Yeah, let's do that instead. All right.
Professor,
Mhm.
Professor, what's the question? What's the question? Is that mean question?
Quotient means divide.
Oh, question means divide.
Yeah, yeah. So if we go back to that original file I sent you, let's see. Most of the time, I can't guarantee it, but most of the time, they will use something like something off of here. And then that's your little like cheat sheet for what do the words mean. Okay. So let me get rid of this. So I purposely put that because that's probably the word that is the least recognizable on that list. So here's my equal. And I have a subtraction and a than. And I have a times. Okay. So a number less than 8. So this one right here will be, we're gonna have to switch sides, 8 minus x. And then this says twice. Okay. Is equal to, and then we go backwards here, I have a plus and I have a divide. Okay. Now notice that there's no words from or than here. So we're going to keep this in the same order. So I should have 10, 6, and 8 in the same order because there's no word than or from. Okay. So the only key is where's my parentheses? We're going to, this is the rightmost one. Okay. So we have 10 plus 6 divided by 8. Right? Do you see how that is? Because there's no word from or than, 10, 6, 8. They keep their same order. Okay. Same thing over here, right? Because we have the than, the x and the 8 switch. Otherwise, it's 2, switch 8 and x. Okay. So we get 2 times 8 minus x is equal to 10 plus 6 divided by 8. So 16 minus x is equal to 16 divided by 8.
How did you
16
know
minus,
to- Sorry,
Go ahead.
how did you know to divide the 8? Because like when it says and 8, I just assumed like plus 8.
oh, so remember that quotient means divide.
I guess. Okay.
Yeah, I was
So-
thinking same and plus, right?
Huh?
And means plus, usually and means plus.
Yeah, it can, but if you did 10 plus 6 and 8, where does the quotient go? This has
My-
2, right? So
My,
if you
my
did
question
that,
about
you have that hanging. Say that again.
Professor, sorry. The question I have about that one, it says 10 plus 6 and 8. So if you put the division before the 8, why would you have to put the parentheses?
Well, if you did this, 10 plus 6 divided by 8, let's say you
Correct.
didn't put the parentheses. This is 10 plus 6 divided by 8. So I always just put the parentheses there because you'll get the wrong answer if you do that one. Do you see that?
Got it. Thank you.
Okay, thank you. Thank you for the question. So then let's look at what happens. So now we have, we'll do it the Russian way. Minus x is equal to, since everyone likes that way better, minus x is equal to 2 minus 16, right? So what we do is when we bring something to the other side, we just change the sign. And we go minus x is equal to minus 14, and then we divide by minus 1.
Professor, a quick question.
Sure.
Since you distributed the 2 and the 8 to make it 16,
Uh-huh.
wouldn't it be 16 minus 2x?
Oh, you're right. It is.
And I got x equals 7.
You're right. You're right, and I'm wrong. So there. So okay, so let me clean that up. Thank you for catching that.
You're welcome. I'm like, wait, you're confusing me.
That hasn't been, that's not the first time. Okay. So then we go divided by minus 2, divided by minus 2, and then we go x is equal to 7. Thank you for the correction.
There we go.
There we go. Go ahead, tell me. You're a good boy, Dr. Kwai. You can do it.
Because I
Pat me
was
on the back.
so confused.
All right. Okay, so go ahead, write that down. Now I'm gonna put a new thing in the table, in the chat. Okay? So these ratio word problems. So this is part of your homework, but I want to do a lot of these problems with you. Okay. Yeah. We may not get to all the homework, so I may cut it down a little bit. So if that happens, don't worry about it. I will organize everything just like I did last week, where I give you the homework. I'll write what the homework is. I'll give you all the solutions. I'll send you a YouTube, and I'll send you a picture of everything we've done. Does anyone need more time to copy?
I don't.
Okay, you don't. Does anyone remember seeing these questions on the exam?
Oh, definitely.
Definitely. Okay. All right.
Yeah, there was
So-
a few.
It was just like this.
Yeah, kind of.
Okay, so most likely, I'm guessing you'll get one of these questions on your exam. I think it's fairly consistent that you get one. Now, I can kind of guarantee you that this next topic, you'll get at least one. You may get more than one because there are a lot of ways to ask this question. And it's actually, like a lot of the stuff we're doing is just not in your nursing classes, right? what we're going to do next is 100% absolutely in your nursing classes. So these are what's called ratio problems. Okay. Now, most of the time, we can often do a ratio problem just in our heads, right? So if I said something like 3 out of 4 kids are girls, if there are 3 kids, sorry, not 3, 8 kids, how many are girls? So don't do math. Just use your intuition. Just use your intuition.
5 girls.
5 girls, yeah. Not 5.
6.
8 is how many times bigger than 4? It's twice as big, right? So there should be, there should be 2 times 3 is equal to 6 girls. Does that make sense? Right? If 3 out of 4 kids are girls and there's 8 kids, right? This number is twice as big as this, then there should be twice as many girls. Just right, if we take a step back and just use our intuition. If I say that there are 12 eggs in a carton, how many are in 2 cartons? You know, like 24. I go, yeah, you just multiplied by 2. You know how many, right? If I say how many cans are in a 6, if I bought 5 6-packs of beer, how many cans of beer do I have? 5 times 6, 30. Yeah, 30. You just multiply, right? We do this in life all the time. Okay. So let's use our intuition again. Let's go. Okay. How many are boys? Don't use math. Just use your intuition. I've got 8 kids.
2 boys.
2. Okay. So we're gonna excuse. We're gonna say we're not gonna look at we're gonna consider gender binary in this case. Right. I'm not gonna try to insult anyone. That's not what I believe. So in terms of non-binary, gender fluid, all that kind of stuff, we're just gonna think of it right now just as binary for the sake of this problem. Okay. So over here we have 8 minus 6 is equal to 2 boys. Okay. So I understand that this is not like a proper question, but I'm just trying to use people's intuition. I understand the gender complexities of this question. Okay.
I have one question, Professor.
Yes, yes.
The first one you say how many are girls? You say why is this 2? Where is the 2 coming from? The 2.
Oh,
the 2.
so okay. So when there are 4 kids, how many girls are there?
Okay, 3.
3. Right. So when there's 4 girls, there's 3 girls. Do we agree with that? Okay,
Oh,
I'm sorry. When there's 4 kids, there are 3 girls. Do we agree?
Yes.
How about then when there's 8 kids?
8 kids, 6. Okay, got it.
Right,
Okay.
twice as many. Okay. Now the problem comes when we say I have something like this. Now let me get away from this. This was an example I've always used, and sometimes it's habit, so it sometimes messes me up in this age in which I think we have to be gender conscious, which I agree with, but again, it's old habits. Okay. So let's look at this. So let's say a bag has, for every 5 balls, for every 5 red balls, there are 2 green balls. Okay. Now, if I said, hey, there's 10 red balls, or 15 red balls, or 20 red balls, using this as an example, most people would be, okay, I can do that. Why? I just, those numbers divide by 5. Now, the problem comes when the numbers don't divide evenly. So if I say, there are 17 red balls, how many green balls are there? And we're going to allow fractional balls. Okay. So we're going to allow fractional balls. So you can have half a ball, 2/3 of a ball. Okay. Now that one's not so easy because you look at this and you go, 5 isn't divided into 17. So there's a problem here. Okay. This is where we use this concept called ratios. So what we want to do is say like this. Okay. So if we just use our intuition, if I go, I have 5 red balls and then I have 2 green balls. Well, it's equal to, if I have 10 red balls, I have 2 green balls. This divides into this. Just like if I said I have 15 red balls, then I would have 6 green balls. When we have this proportion, for every 5 red balls, there's 2 green balls, each one of these fractions are equal to this. So I have red, red, green, green. Okay, red, red, green, green. Notice that, the units? Well, let's do the same thing here. Okay. I have 5 red balls and I have 2 green balls. So I want to have red and then I want to have green. So this is 17 and this is X. Okay. Now, when we have, um, gosh, my brain just froze. When we have a fraction equal to a fraction, a fast way of solving this is what's called cross multiplication. Meaning that in this diagonal, I can bring the X up here and the 5 down here. And then this diagonal, I can bring the 2 up there. I have the option to bring this down there, but I don't want to. The reason why is that I want this to look like X is equal to something. So my X is down here, I'm going to bring it up here. And then I have the 17, I'm going to keep it on that side. The 2 has to, from on this side, has to go up. And then the 5 goes down.
6.8.
Sure, 6.8, yep. Okay. So let's try this again. So let's use the same information. Okay, using the same information. If there are 15 red balls, how many green balls are there? Now, it doesn't matter. Yeah. Huh?
6.
No, it's going to be some fraction. Oh, yeah. Wait, did I do that right?
No, it's 6.
Oh, I'm sorry. Did I mess that up? I did mess it up. I want this to be green. So you're right. It is 6. Let's make that right. I wanted to make it opposite. Okay. Now, it doesn't matter whether the red is on top or the green is on top. The only thing that matters is the units match this way and this way. And these are the smaller numbers and these are the bigger numbers. Okay, so you can do greens on top, you can do reds on top. It does not matter. The only thing that matters is that horizontally the units match.
$37.5.
Let's see, I haven't done it yet. Let me see, let me catch up to you, right? So I have 15. Well, okay, let me go. I have 5 red over 2 green. And then I have 15 green over X. So I'm going to bring this up here. Oops. So we have X is equal to 5 times 15 divided by 2. So that is 75 divided 2. And then what did you tell me? 37 and a half? Or
Yes.
37.5? You got it. Okay, let's try another one, right? Let's try another one they try to trick us with. Okay. Okay. Now I'm gonna apologize in advance for those who are offended. Unfortunately, the word problem worksheet I give you are going to treat boys and girls as binary. That's just the typical ratio worksheet there is that's out there because sort of the public acceptance of like gender spectrum is newer, and there's just a lot of the textbooks and worksheets that are out there just haven't been updated. And you could see that I'll every so often just make that mistake. So for those of you whose feelings are hurt, I deeply apologize, and I agree with you that it's offensive, and I'm sorry, but it's what I have. So I want to apologize in advance. Okay. So if there are 20 total balls, how many red and green balls are there?
Professor,
Yep.
do we use your previous you look at the 6.8 is green ball, is 37.5 is red ball. You said if there are 20 total balls, how many red and green balls are there? Can I do 20 minus 6.8 is green ball?
No, because this one is for this one's 17 balls, so it doesn't. This is 20. Okay, so all right. So if you guys are confused, good. I meant to have you be confused, like have a wait a second moment. Okay.
Use this
all right,
is
so
separate question or connect.
connected to this one.
pi-
So each one of these are connected to this one.
Oh, okay. Thank you. Got it. Thank you.
All right. So let's talk about it because this is confusing. We haven't gone over this. This isn't obvious. No. There are 5 plus 2 total balls. Okay. So you can either say, oh, I'm sorry, let's say equal to 7. So you can pick this number and either one of these two. So I can say 20 total over, and let's just pick a color. It doesn't matter which color you pick. I'm just going to pick red. Is equal to, for every 7 total, there are 5 red. So you know how many total balls there are, right? So for every 7 total balls, there are 5 red, and for every 7 total balls, there are 2 green. So this is, if they want to make this the hardest way, is they give you these two and ask you for this, or they give you these two and then ask for this. So just so you know that you can always find the answers by saying, well, if they gave me this information, there are 7 total balls, 2 are green. Then you go 7 minus 2. Well, 7 minus 2, 5 are the other kind of ball, right? So understand that there are 3 numbers here that they can ask you for, and they'll only give you 2. And you have to use your intuition to find the other one. Okay. So when we do this, let's bring the X here, X up here. And then the 5 up here, and then the 7 down there. Okay. So I get 20 times 5 divided by 7 is equal to X.
100/7.
Okay. So I get roughly, X is roughly equal to 14.29. We'll round it. Now you could do the same thing doing a ratio problem, but it's probably faster to say, so this is red balls. So green balls is equal to 20 minus red balls. .71. Okay, so let's take a picture of this. Okay. So let's look at this ratio worksheet. Okay. So let's just start doing some of these problems, right? Does anyone need more time to copy? I can wait. Okay, so let's try this. And actually, let me try this. Okay, and then let's get rid of this. And it's not gonna let me. I guess it won't let me do that. All right. Give me 1 second. New share. And this. Okay. Okay, so let's go down and look at let's look at number 4. Okay. And then I put this in the chat. Okay, now this isn't even ratio. This is just you using your intuition, right? You do this all the time. You compare prices all the time, right? So I just want to make sure that you don't get so freaked out that you forget things that you've always done. So you go 1.44 divided by 3 is equal to, where's my calculator?
48 cents.
48 cents.
Yeah.
And then 2.50 divided by 5 is equal to 0.50. Okay. So the one that is better is Quickie Mart, right? So this one's better. Okay. So let's not lose our ability to just use intuition. Okay. But let's try different. Okay. Let's try doing let's try doing number 2. Oh, you know what? That's too straightforward. 252 divided by 12. I think that's a. Okay, let me get a better one for you. Okay, let me let's go down a little bit. Let's clear everything here.
21 drinks.
Yeah, that one's straightforward. Let me do one that's a fraction. Okay, let's do number 1 at least.
3 to 5.
Yeah. So when they say ratio, and then let's not yell out the answers, give everyone a chance to sort of think about it. Okay. Now, whenever they say ratio, okay, what a ratio is just a different way of writing a fraction. Okay. So what you want to do is turn that into a fraction. And then you want to simplify that. So
Well,
that
then-
turns into 3/25. Okay. Now that's a fraction. The way you write a ratio is going to be 3:25, or you're going to write it as 3/25. So the first number is the numerator and the second number is the denominator. And you always want to simplify it as if it was a fraction. Okay, so let me take a picture of this.
I have a question, Professor.
Yes, please.
You say, so what's the 50 coming from?
It's supposed to be 20, not 50.
Oh, is it?
Huh?
Oh, the number. Oh, I'm sorry. It's my dyslexia. My bad. Okay, thank you. 5. Okay, that's 5. All right. Thank you. 5. And then 5. Okay, is that better? All right.
Yes, thank you.
Good at math and bad at seeing. All right, let's do this again. All right. Now, let's look at let's go down a little bit to where when they start getting a little less intuitive. Okay. Oh. Huh. These are all intuitive. Okay. Let me go back and look at a different worksheet. Give me 1 second, okay? I had a different worksheet that was a little bit more difficult. Give me 1 second. Huh. Give me 1 second. Let me look one more place for it. I apologize. I had a really good worksheet on this that. Okay, give me 1 second. Oh, okay. Okay, well, there's a different worksheet I gave you that'll give you. I gave you 2 ratio worksheets. So one is pretty straightforward, and then the other one is just like what we just did. Okay. Now let's work on unit conversion. Okay. So let me go back to where we were. Give me 1 second. Okay. Now, I know a lot of you aren't going to want to memorize this chart, but you're going to have to memorize this chart. You know, like, why do I have to memorize this chart? Okay. When you get accepted into the nursing program, they're going to give you an exam in the very first few weeks of the class. Here. And they're going to ask you to memorize everything on this chart. So go ahead and download that. And then go ahead and download this right here. Okay. Now let's look at that TEAS unit conversion. I grabbed this. Yes.
I'm sorry, Professor. Could you send this TEAS unit? Oh yeah, yes. Could you send through the email? Also send us
You already
email?
have it. I already sent
Okay.
it this morning.
Thank
Okay.
you.
No problem. Now I know this isn't great. I Xerox this off of an old TEAS manual. The current TEAS manuals, they ask these questions, but they don't give you this chart. So this is the chart. You know, talking to students, they kind of limit themselves to this chart. Now, the reason why you want to use this chart and not any other chart that you read off of Google is because these are the assumptions that the nurses make. Okay. Now, I want you to see that 1 yard is very close to a meter, but not exact. So in terms of the nursing exam, you can consider a yard and the meter the same thing. Same thing with this over here. A quart is not quite a liter, but on the nursing exam, you can assume a quart and a liter is the same thing. Same thing with weight, and same thing with ounces. Okay, so these approximations are standard for nurses. They would not fly if you were a physicist or a chemist, but this is what the assumptions nurses make. Now, we have two different groups of measurements. Okay, we have English measurements and we have metric measurements. Okay, so English is what we use in the United States. Now, in order to go from English to metric, you go through this. So if I want to convert feet to hectometers, I would go from feet to yards, yards to meter, and then meter to hectometer. Okay, so I just want to understand that, right? So this right here tells you always convert to yards, change the meter, and then convert. Okay. Same thing here. No matter what they give me, if they give me cups, no matter what they give me, go to quarts. Quarts then turn into liters, and then liters then turn into one of these. Okay, so okay, now on your homework, you have some questions that say mild. You don't have to worry, ignore them. Okay, there are no miles on your exam. So anything that says mild, miles per hour, don't worry about it. You're not using it. So miles per hour, knots, anything that has miles in it, forget. Okay, so let's look at this. All right, now, so okay, let me not say if, when you make it. Okay, so let's say you get accepted in for the spring. What they're going to tell you is, hey, congratulations, you made it. 2, we are going to make you bust your butt. 3, school's going to start before school starts. Before you even walk into the class, we want you to go and meet Dr. Kawai for 6 hours. And we're going to have 6 hours worth of lecture on exactly this, converting units. So even before class starts, they go, we don't even want you in the class before you sit down with Dr. Kawai and you learn how to do this, period. That's it. Okay, let me print this out. Okay, so whether you like it or not, you're going to have to memorize this, period. Now, at the beginning of every semester, there's 4 semesters, they're going to give you a dosage exam which has these on it. If you get one wrong, you don't get to take your classes. You get to take the dosage test 3 times. And if you fail it 3 times, then they say, we have the option to drop you from the school. They usually don't, they work with you. But if you are just not getting better at this and just refusing to memorize it, they'll say, we really don't need you to be here. You are an unsafe nurse. A nurse who can't convert units is unsafe. You're going to poison someone. Literally. So when I ask them, how come you're so strict on this 100% thing? And they always tell me, John, how many people does a nurse get to poison? 0. Period. These things have to be automatic because you can't guess. You can't get this wrong. You'll poison someone. Okay. So even though this list is intimidating, I would recommend memorizing it. And I can guarantee this will be on the test. Because of all the things in math they want you to know as a nurse, it's this. Okay. So let me teach you how to do this. Now, if we think of something like 1/3 plus, I'm sorry, let's go 6 plus 5/6. I'm sorry, over 3. If I was to ask you to add those two fractions, the first thing you need is a common denominator. You don't have to copy this, just watch. Like that. Now, understand that 2 divided by 2 is equal to 1. And 1 times any number is the same number. So 1 times 3 is 3, 1 times 4 is 4, 1 times 18 is 18. Multiplying by 1 does not change the number. It only changes what the number looks like. So when we look at this over here, this fraction is equal to the fraction, this fraction. They just look different, but they represent the same amount. Okay. So when we do this kind of thing, where we say, let's do one that's a, how many inches are in 1 yard?
Ninety something.
I don't know. Let's see. Okay. Now I want you to see that there's a couple relationships. We have 1 yard is equal to 3 feet. So I can think of this as 1 yard over 3 feet is equal to 3 feet over 1 yard. They're the same amount. They would cancel each other out and become 1. Right? So when they say something is equal to something, what they're trying to tell you is that you can use this fraction. Either this is on top or this is on the bottom. And in the same way, they'll also give you that 1 foot is equal to 12 inches. So what this infers is that you can use 1 foot over 12 inches, which is equal to 12 inches over 1 foot. And both of these are equal to 1. Now, we haven't explained what use means yet. Just copy this part down, this part right here. Okay. Now, let me show you how you convert units. This is what you probably did in chemistry. Okay. So we're going to start with 1 yard. Now, I need to convert this to something that has yards in the denominator. So when I look at what I have over here, this one over here has yards in the denominator.
Because I got 36 inches.
Okay. Don't yell the answer. Give people a chance to think.
Okay, thank you.
No problem. Okay. You're correct though, right? You're correct. Now after that, we're going to multiply. Okay. We then want something that has feet in the denominator, because what we want to have is we want this to cross out with this and this to cross out with this. So when I look at this over here, I know that feet's in the denominator. So I have 12 inches is in 1 foot. So that's going to be 36 inches. Okay, so your units will cross out just like numbers do. Okay. Now let's give you a harder one. Okay. Now, does anyone have a question of how I did this? You should have seen this in chemistry, I assume. Okay, so let's do this. Let's go 5 feet is how many centimeters? Okay. And then you go, is this done? Absolutely. In the US, we measure things by feet. In Asia, they'll ask you like how many centimeters are you? Okay. So just to give you a map, you want to go from feet to yards to meters to centimeter. Remember that, right? For length, yards is where you do the crossing between um, um, English and metric. Give that a shot. Don't yell the answer, but give it a shot.
Professor,
Mhm.
Professor, 1 meter equal to how many centimeter?
Okay. So let's remember. Okay, so 1 meter is equal to 100 centimeter. That. Oh, so you're asking a really good question. In terms of this chart, it says like 1 millimeter is equal to 0.001 meter. I don't like using that. This is the only thing I don't like about the chart. I would do 1,000 mm is equal to 1 meter, and then 100 centimeter is equal to 1 meter, and then 10 decimeter is equal to 1 meter. So I would do it this way rather than memorizing the 1 millimeter is equal to 0.001. This is the easier way to memorize. Same thing with millimeters and milligrams. Okay. So let's try this. So we have 5 feet times, so I need feet here and yards here. So 3 feet is 1 yard times, okay, and we said, so we need yards here, meters here. So 1 meter is 1 yard. And then we have 1 meter is 100 centimeters. Okay. So let's look at that. So I have 500 divided by 3 is 1.66 166.7 if I round. let's try another one. So let's try some more nursing ones, right? The kind of ones that you would see in a nursing class. Okay. So let's say that okay. All right. So let's convert 4 cups to milliliters. It should be a lot of milliliters.
How many milliliter in 1 cup?
Huh? Well, we have to use this chart, right? We have to go from, we don't know, we don't have a direct translation. We have to go from cup, dot, 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 and then we have to get to quart, and then quart goes to liter, dot, 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 and then we go to milliliter. So you got to figure out how to go from cup to quart, and then these are the same, and then go from liter to milliliter. Okay. So I have 4 cups, and then I have 2 cups is 1 pint. And then 2 pints is 1 quart. Okay, now keep it going.
One quart is 1 liter. Yeah.
Yes, 1 quart
That's
is 1 liter.
quart is 1 liter. Is 1 liter is one.
Yeah, but
100
wait, stop. Let everyone else figure it out, right? Give everyone else time. So if you
Okay,
got it, that's good, right? But let everyone else have time to like think about
Professor,
it.
Professor, you are this pen. How to spelling this words? PRNT.
Yeah, pint.
PRNT.
PINT. Yes.
Okay.
So a pint is about, like, you know, when you go to a bar and drink some beer, that the cup that you drink beer from is about a pint. Now remember, we said quarts will connect with liters. So 1 quart is equal to 1 liter, and then 1 liter is 1,000 milliliters. So this should be equal to, the 4s will cancel, and I should have 1,000 milliliter. Okay. All right, let's try this again. And let's go 20 ounces. Oh, convert. 20 ounces to milligrams. Okay, and this is going to happen in your nursing class.
So, Professor, do you teach nursing schools too? Nursing
No,
schools?
I only so I am full-time here, and I'm a math teacher. I don't know any nursing at all, but my wife's a nurse, and I'm nice. So they asked me to teach this class, and they go, "Could you teach this class?" I teach this class. There's no nursing in here, so I know it's on the nursing exam, but there's no nursing stuff. So then I teach this, and then they go, "You seem really nice. The students like you. Do you want to teach dosage? Because there seems to be like." The nurses, the teachers, they just kind of look at it and go, "Yeah, the answer is 14 grams." They're like, "Well, how'd you get there?" Like, I don't know, seems obvious. So the students get like frustrated, like, "Wait a second, could you go step by step like math?" They're like, kinda. So the nurses all do it, but they've done it so often. It's like one of those things that's so instinctual that they just spout out the number, but it's hard for them to go step by step, like this. So even my wife, I have her double check the exams they give, and then I'll do the exam, and then she'll do the exam, and we compare. My wife will just spit out the numbers. I'll go, "How'd you get that?" She's like, "I don't know. It's 20. So they asked me to start teaching that only because you're like, "Well, you're nice, you know math. This is math with nursing." And because my wife's a nurse, they're like, "Just ask your wife. Every time you have a question, ask your wife." So when we do syringes and stuff like that, I'll just ask my wife, like, "What's this? How's this syringe thing work? Or how does this medical device work?" And my wife will explain it to me, and then I'll like, "Oh, okay, then the math works like this."
Okay, Professor.
Uh-huh.
Professor,
Mhm.
look. 20 ounce times is 1 ounce is 28 gram.
So
1
let's
ounce
see.
is 1 ounce is 28 grams. 1 gram is 1,000 milligram.
Yep. So we can go. Well, let's do
20
this.
20 ounce.
You're correct. You're correct. 1 ounce is 28 grams. So we'll go
Yes.
20 ounce times
Yes.
28 ounce to 1 gram times 1 gram is 1,000
1,000 milligram.
milligrams. Yeah.
Mhm.
Now, the other way you can attack this problem is that a lot of times the students don't remember the ounce to grams, but they remember the kilograms to 2.2 pounds. So the other way you could do this is you go 20 ounce, and then you go, 20 ounce times 16 ounces is 1 pound. Now the kilograms to pounds you will use constantly in nursing. So this is the one that students usually remember the best.
Wait, isn't it 1 ounce 28 grams?
Yes, 1 ounce is 28 gram. Yes. It's
You
1
wrote
ounce.
gram
1
and-
Oh,
ounce.
did I have
is
it backwards? Oh, I'm sorry.
Yeah, so you confused me for a minute.
All right. Okay. So the way that I think nursing students usually do it is that they usually remember that 2.2 pounds is 1 kilogram, and then you go 1 kilogram is 1,000 grams, and then 1 gram is 1,000 milligrams. You don't have to do it that way, but that should give you roughly the same answer. Okay, so let's do the top way because that's a much shorter calculation. So
Okay,
we go
Professor, I have
20.
a question, Professor.
How can I help you?
Question is This is no. And one is what's that? What's the words? No. I'm not saying.
Which one?
I'm saying is IB. IB was that stand for?
IV?
One, no. IB B pounds.
IB?
Is
I don't know
pounds?
what that is.
No, you told
Oh,
you,
LB. Oh, what I wrote? Oh,
It's LB.
LB. This is pounds.
Oh, that's pounds. And 1/16 ounce also is pounds. 1 pounds. 1/16. Just the first step.
Yes,
1/16 ounce. Just
yes.
also is 1 pounds. LB.
Yes.
Oh, okay.
So
got it.
LB is a pound. I apologize
Okay.
if I.
Got it.
it
Thank you.
wasn't correct.
No. You're okay. Thank you.
Okay. So that's 12, everyone. I really appreciate how hard everyone's working. So this one's pretty important. It's a lot of work to get there. So, but I think if you do memorize this chart, it'll make your nursing life way easier. Okay. The first day when I walk in, everyone goes like, "What?" You go, "Yeah, you're gonna have a test in about 2 weeks, just so you know." All right. See you guys next week. Please do your homework. Please
Professor, have
email us.
question? Professor,
Sure.
question. Have a question. My question is, your homework you through our you already sent the email for us.
Yes, I already sent it to you.
Is the homework we do will be next